Today we're going to talk about the basic bit instructions that probably make up 78 to 80% of most of your Studio 5000 programs. So a little bit about where we're at is if we go to twcontrols.com and we go to online courses, then you're going to see the Studio 5000 RS Logix 5000 courses. And if we click on it, this is a free course, by the way. Then if we go down, we have the Comprehensive Guide to Learning PLCs. And we've gone through how to select the correct version of Studio 5000. We've gone through our wiring and troubleshooting our wiring to make sure it works. And last, we went through how to configure our PC to communicate with our PLC. And now we are in the basic bit instructions here. So we're going to be in Studio 5000, and I'm going to build this up in two of Studio 5000. So we have, just out of reach here. Your trainer can either come with the compact guard Logix PLC, or it can come with the compact Logix PLC with the built-in I/O. And even if you're not using one of our trainers, I believe that these two right here build out most of what we need to know about our local addressing. So now, one other note for instructors, kind of funny. I try to serve a lot of audiences with this new series. A lot of instructors are like, yeah, we need long burn videos where we can put a student in front of it and we can just sit them there and learn. And some of you are, as soon as they came out, you're like, hey, these are too long. I only get like 20 minutes with my students. So we're actually going to go through in this video, first, how do we create a new program and configure our modules and understand our addressing? And arguably, that's one chunk right there. And I'll try to maybe break this up into chapters later. Then we're going to learn about our basic bit instructions. And then we're going to learn how we can combine these basic bit instructions and start to really do some, not advanced, but some basic programming with it. And really, by the end of this video, you probably can work your way through probably 70 to 80% of the programs that are out there. So we're going to start or in your case, you're going to start the new program that you need to start. But for me, I've got two blank programs here ready to go in Studio 5000. Now, one other thing, because depending on which trainer of ours you have or what you're working with, the one thing as you're creating a new program is you need to know which version of your PLC that the firmware that's in it, because especially like on this image here, I have version 37 and 36 created. If I create a program in version 37, later I can't switch it to 36. So let's check what version we're running in our PLC. So I'm going to go Communications, Who Active, and we're not actually going to go online or upload or download or do any of that. All we're going to do is take a peek into our PLC and see what we have here. And then actually I'm going to close this up because if you remember from the last video, I made this little subscribe one here, and here's the trainer that I'm going to be working with today. So I'm going to right click this trainer and I'm going to go to device properties. I said right click this trainer. You're going to right click your PLC because chances are if you have one of our trainers, you also have a PowerFlex drive. You may have an iLink module, motion controllers, HMIs, all types of fun things. But we're going to find our PLC, which either starts with 5069 for the compact guard Logix or 1769 for the compact Logix, and we're going to go to properties. And here on this one, I'm running version 37, so that's what I'm going to need to do. Now, check yours, and don't worry about upgrading yours right now. We can learn about all that later. If yours says version 30, we're going to select 30. Now, you want to select whichever version that you see right there. So now I'm going to close that, and we're going to go File and New. And then sometimes it can be really difficult to figure out which one of these folders that you actually need to be in. And so you have a search bar up here and just start typing the part number of your PLC. So in this one, I'm going to go for the compact guard Logix. That's 5069-L306. And then it's an ERS2. So that's the one we're going to do here. And I'm going to call this my bits 5 069. All right, let me get those with the compact logics caught up. So we're going to go to the other one, and I'm going to go new on this one. And in this case, it is a 1769, and it is the L16, and then you only have one option left, and it is the ER-BB1B. We'll select that one over here, and I'm going to call this bits 1769. I'm going to hit next on that one, and then we'll go over here and I'll hit next on this one. And this is the important step I was talking about. So if I had version 35 in this PLC, and if I selected version 37, it's really difficult to back or downgrade a Studio 5000 program. It can be done, and there is a video actually already in the course. There is a video in the course about how to downgrade it, but try to select the right version right off the bat here. And we're going to hit finish, and then we'll come over here. I'm going to select version 37. And then notice on this one, we're on the 1769 Compact Logix. We also have to select the number of expansion IO. And this is incredibly important that we get this part right when we do it. So on this case, and also in this case, you can have modules snapped on, but they don't make you select it in this. But on the 1769 L16, you have to tell it how many modules you are snapping to the side of it. If I'd been really smart, I would have grabbed a module, but I do have a program open that I'll show you what that looks like. So probably if you're using our default trainer, then you have 0 modules, and you may have gotten some customization depending on what you ordered or what you're using. And so just count up the number of modules that are connected to it. This does not count. This is 0. So in my case, I am going to select 0 modules, and we're going to click finish on that one. Also, one thing I did mention, you probably need to bookmark this area as far as creating a new program. So as we go through timers, as we go through counters, as we go through how to sequence machine steps, adding the PowerFlex 525 to control it, chances are I'm not going to go through how to do what we're getting ready to do as far as creating new programs and configuring our basic modules. I'm just going to start with that part. That way, those that you need to can replay the video. Those of you don't need it, you're not watching me doing the same thing over and over. So this is the 1769. And as of this point, looks pretty much the same as the 5069. We do have a safety task over here that we need to worry about later. But there are 3 areas that really, if I could get everybody to know when to get to, then we would be golden as far as navigating Studio 5000. So first of all, we're sitting here staring at a blue screen, and we're always like, well, where do I go to start? And by default, we have task, main program, and then notice this arrow is closed up by default. This arrow right here may cause more grief than people really realize, but if you open that arrow, then inside of it, you're going to see your main routine. And for the most part, when you're starting out learning, this is where you're going to put your program at, as the main routine. We'll learn about different types of tasks later, but let's go ahead and double click on it. Also notice if you accidentally double click on your main program, you end up with this thing up here. Just close it out. And notice it also hit it back. So that's all I always say in the class. If you see an arrow, click that thing. So there we go. We're going to be there. And over here on our 5069, on the 1769, our compact quad. Oops, I'm in the wrong program. I was like, why does it look like that? There we go. That's what I'm going to show you later. But on the 1769, we'll do the same thing. We'll open the arrow, and then we'll double click on our main routine. All right. And so our instructions that we're going to learn about are actually on the favorites tab. We have this one, we have this one, we have this one. I'm not even calling them out what they are yet. We're going to talk about why I call them what I do in a little bit. But also we have a bit category, and really, oops, missed. There we go. There they are again. So these bit instructions are really the ones that we're looking at. And we're going to learn about these over here in a little bit later video, but these 3 right here are the ones we're going to focus on. So I am in the Compact Logix group, and so if you have the 1769, notice when we open it up, we ended up with this red line already in here. And yeah, we'll talk about what we call that here in a little bit. But for now, we're going to drag this shape right here down, and we're going to drop it. And then we're going to double click on our question mark. And here's where I always stress when people are starting out in my class is I don't care if you were the world's greatest typer in high school. I want you to follow your arrows. One, because we're going to minimize our errors because you're going to find out you're not that great of a typer. You can't figure out what a semicolon or a colon or a dot is yet. The other thing, you're going to start understanding how to navigate the structure in Studio 5000. So we're going to hit the arrow. And then we're going to be looking at local :1:I. And when I get to the 5069, I'm going to explain exactly why we're looking at what we're looking at. And then we're going to hit our data. And then you're kind of looking for an arrow here, but notice now the arrow is on the right side. We're going to hit that arrow on the right side, and we're going to get 0. And then we're going to right-click those words that we just found, that local thing, and we're going to edit main operand description. Now, a lot of people end up wanting to edit properties up here and try to throw a description in here. And we'll learn out on the 5069 a little more about the structure. But notice you're putting a description on local :1:I, not local :1:I .data.0. So we're going to right-click, edit main operand description, and we're going to type green button. And that's going to get us to there. Okay, so now let's go to the 5069. Now, if you're using this PLC, the Compact Logix, don't skip over this next part because while I'm explaining how it works with the Compact Guard that has the modules added to the right side, when you start adding modules, you're going to need to know this part right here. So we are going to go back to the 5069 program. And same thing, we have our favorites, and we're focusing on these 3 right here. They're also over here on the bits category. I'll just stay on the favorites on this one. And we're going to drag this shape down, and we're going to double click on our question mark, and we're going to hit our arrow, and we got a big old blank space here. And I really think that this is what I enjoy doing, or enjoy. I think it's more effective to learn slowly in the 5069 compared to our 1769 Compact Logix. Because what happened over here is when we added our PLC, when we created a new program, that BB1B part that was at the end of that part number actually told it what type of inputs and outputs it had. And so it's configured all of that for you. And that's why when you're in this one, it shows up. Now, in this one, we only configured, oops, let me get I didn't aim my thing. Let's see, get over here. We only configured this red part right here. This is the 5069 L306 ERS2. This module is a 5069 IB16. This module is a 5069 OB16. Now, do this part slowly because I want you to see a few things that'll help us start locking in on where exactly we go for which thing. Because it's funny, even though the first one I showed you was how to get to the main routine, I'll say almost exclusively, you never start out at your main routine. In fact, it's probably the biggest thing when you come to a training to break you up. People always, as soon as they go to troubleshoot the machine, they just go ahead and open the main routine. I'm like, what are you doing? Like, oh, I was just getting it open. We're going to need it in a second. I'm like, no, we're not. It's like, what are your options now that you have that main routine to open? All you can do is scroll. And so the only tool you're using then is your eyes. So for the most part, our controller tags are a better place to start, both when we're creating a program and when we're troubleshooting a program. So at the very top, these little local things that we found here, they're actually called tags. And there are some various other tags, but to start with, we're going to stick mainly in these controller tags right here. So 5069 or 1769 group, go ahead and double click your controller tags. And you're just going to look like this. You have local :1:I, you have local :1:C, and you have local :1:O. Now, the 5069 group, when they go and double click their controller tags, theirs is blank because they had no modules created when they created their program. So your modules are created in this IO configuration section right here. And so if we look at the at the IO configuration of 1769, then they had their point IO and they see the embedded IO, embedded discrete IO. That's how they're getting theirs. All right, let's build it out slowly in the 5069 group. And yes, if you're using the compact Logix, make sure you pay attention because this will be how you do it as you add modules to yours. So one thing that can be a little tricky right here is understanding how these icons are lined up. They are lined up based off of, I'm sorry, I even said icon because it's always stress. All of these organizations are lined up based off of these folders, not off of these arrows. So see how this arrow is kind of kicked out over here? That is not directly inside assets. It's that the data types are. That'll come clear a little later here, but in the IO configuration, we can have 5069 backplane, we can have A1 Ethernet, and we can have A2 Ethernet. That's our three options for adding modules. So later we'll add our PowerFlex 525, and that'll be over A2 Ethernet. But for today, we're going to have our modules connected right to the PLC. So we're going to right-click 5069, new module. And then I want you to use the filter box up here. And you don't even have to type the full thing. And I know half of you are like, oh, I can see the module. But I just want us to get in the habit. That way we're not scrolling and hunting. Is in the filter box, our first module, the end of it says IB16. We're going to type IB16. It's going to narrow us down to two options. That we don't have to do a lot of hunting and pecking. And we have the basic 5069 IB16. And we're going to hit the create button. So I was sitting there on LinkedIn right beforehand, and I ran into this post. Now, he's pointing out that somebody spelled this wrong. If you ever look at any of my programs, stuff's brutally spelled wrong. But what I'm going to point out, and that was what I was getting ready to point out, like next thing, is notice here, this first module is labeled as Input Module 1. The second one is Input Module 2. The third one is Input Module 3. I already know it's Module 1, Module 2, and Module 3. I can see in the IO configuration. At the point we're looking at this module, we need to know something to help us figure out what's going on, either in the field or something. So the best description I see on modules somehow connects us to the wiring diagram. Like, even if we name it PLC trainer, that doesn't help us any. We already know it's a PLC trainer. We already know it's an input module. But somehow associate it with something. Now, just so we see what it's going to look like, I mean, I'm going to name this inputs. Now, I would not want to do this next week, but we're going to call that inputs, and we're going to hit OK. I hate to cancel it because we already had such issues. Okay, well, you're probably looking at your controller tags. Yours probably worked fine. But notice as you hit the OK button, and I'll quickly get there, you ended up with local :1:C and local :1:I. Also need to get the 1769 back open. But all right, so we want to look inside of local :1:I. I want you to hit the arrow to the left of it. And you're going to see a lot more items than the compact Logix group's seeing. Should have opened that up first, but I was holding my breath that that the module would open up. Now, it seems like once it works, it works for the rest of the time, or at least last time. Let's see, Chad, I think we all have a loving, well, in there, I downloaded an update, and maybe there's something quirky with that update, and they'll fix it. They may have already even fixed it. It's hard to say, but all right, we're going to go back to this one and open up the controller tags. And so for the compact Logix group, open up your local :1:I, and you're going to see fault and data. I want you to go on into data, and there you're going to see inputs 0 through 15. Now, over on the 5069 group, you have some really cool stuff. You've got some diagnostic stuff, you got some diagnostic sequence count, and then you have PT00. And you have to open the arrow up, and then you see your data. But also, you notice you see fault and you see uncertain. And we're going to talk about these in later videos. I'm not seeing these utilized nearly enough in PLC programs. But these are ways that we can add some diagnostics data about open circuits, short circuits, all types of cool things. But so that gives us our local colon 1 colon I PT00.data. Now, your second module is a 5069 OB16. So we're going to right-click backplane, new module. I'll hold my breath and hope this works. We're going to type OB16. And we have a basic 5069 OB16. And I'm going to hit the Create button. Yeah, I mean, I don't know what's up with that not working sometimes. Again, I say next week, that's usually when you're out of my class, but yeah, you're watching this video. But when you're doing a real project, do not name this outputs. But I do want us to see what this looks like. So I am going to name that outputs, and we'll click OK. And now we can close that creation dialog box. And if we scroll down a bit, then we're going to see we have local colon 2 colon C, local colon 2 colon I, and local colon 2 colon O. Now, this is an output module. So for the most part, when we're trying to control things, we are going to go to local colon 2 colon O. And then you're going to see PT00 data. You open up data, keep opening data. Now, also notice for later videos, you have local colon 2 colon I. Now, that seems a little strange at first, but it is an output module. But if we want to learn something about the output module, if we want to look at something that is still an input. So we have some incredibly cool inputs on this module. We open up local colon 2 colon O, go to 0.00, then we can tell, one, no load. Have we burned an output coil up? Is there nothing connected to the wires? A fuse blown? And then we can see a short circuit. And so, yeah, it has something, piece of conduit got smashed, something happened. So this is some really cool diagnostics I'm 100% seeing never used in people's programs that we want to learn about later. But all right, let's get back to square one. Let's get back to the basics where you're at. We were over here in our main routine, and we were here. So now that we've added that module, we can go local colon 1 colon I, PT00, and then data. Okay, now over on the 5069 group, I had you, let me get back open here now that we had to close everything. It'll take me a while to get all those back open. I had you right-click this and edit main op description and put your green button in there. Now, there is a small consequence to doing it this way, and here's why I say, we started a little backwards because I wanted you to see this, but this is why I kind of say start at your controller tags, even on this. Is we're going to go back over to the 5069 group, and we're going to right-click, edit main operand description, and we're going to type green button. And now, both groups go look at your controller tags, and if we go look at local colon 1 colon I, PT00 data, it does have a green button. But by default, as you're scrolling through your program, these are closed. So now we can't figure out that this is the green button without opening up and seeing this data right here. So watch this. We're going to highlight that, right-click it, and we're going to cut it out. And now I want you to take local colon 1 colon I PT00. We're going to right-click there, and we're going to paste. And that is going to let that description fill into all three of these. And mainly now as we're scrolling through, we're going to be able to see which one is which. And same thing over here. Oops, wrong one. Same thing over here. It fills in the green button still, even though we have it on local colon 1 colon IPT00. Okay, so let me get, now it's like, all right, what all do I have to get open back up where I did that reboot? So now what we want to do is we want to put our descriptions in, and we're going to do it on both 5069 and the 1769. As if you recall from where we did our wiring, here's our getting started guide. And in step 3, we had our wiring it up to get started diagram. And then our 5069 is on right now page 3, but you never know when I'm going to update it. But look over here, this says RA 5069. And then here's our RA5000. The RA5000 is for the compact Logix users, the ones that are using the 1769. And this is the 5069. Now, notice they do line up. It's just that I've added more to it. And I probably should update this one to do the same. So now we're going to fill in all of our wiring descriptions. So we already have PT00 as the green button. The next one, we're going to make the yellow button. The next one, we're going to make the red button. Next one, we're going to make the blue button. Whoops, and I'm labeling them as a color. It does say button 1, button 2, but usually when I'm talking about the videos, I do tell you the button color. So I'm going to do that. Then switch 1. Oops, maybe I'll spell switch right. Then switch 2. Then we have switch 3 left. Switch 3 right. And then input 8 is switch 4 left. And 9 is switch 4 right. And then input 10 is our relay contact. So even though we're not using all those, what I would say is when you're starting a program, the first thing you want to do is you want to fill out all your IO. So there's our inputs. We'll close that up. And then let's go look at our outputs. So let me close some of these areas up because I was opening them up showing you how you had to do that. And so this is point 0 is going to be our green light. What is our yellow? Red light. Blue light. And then our relay coil. So it gets all our inputs and outputs. All right, now let's talk a little about this addressing before we move any further. So we have on the 5069, we have local :1:I, and then really we're using local :2:I. So first of all, local means it is physically touching the PLC. So this drive right here we'll be controlling later on. It will not be local because it's over Ethernet. This IO link will not be local because it'll be over Ethernet. This linear actuator will not be local because it'll be over Ethernet. Only the modules that are snapping on the PLC are local. And this is very important. It's funny. Tuesday, this is like the review because I'll ask them, okay, if it's touching the PLC, what's the tag start with? Local. If it's not, what's it not start with? Local. If it's touching the VIN, I'll repeat it like 5 times. And I always tell them, okay, because somebody's going to get upset with me a little bit, and I'm going to tell you, take your hand off the mouse and take your finger and you trace that wire out and tell me what it's touching. And if it's not touching the PLC, should you be going through your local tags? So that's our first thing is figuring out, okay, what does the tag name start with? But okay, so then we have a number here, and this is important even in the 1769 group that has a built-in IO. We have a 1, and then we have a 2. Now, on a PLC that does not have built-in IO, 1 is your first module, 2 is your second module. Now, here's where it gets tricky. On a PLC that has built-in IO, the built-in IO is 1. Your first module is 2. Your second module is 3. And now I got to get that program back open. All the fun when you have to do a reboot. I'm going to get that open while we go look at this. So let's see, go studio again. And that was the Island Compact. That way that's opening up. So in here, if you don't remember, and here's as I always say, and here's the important piece. That's why I wanted to stress this is if we're not sure, when you hear this colon coming out of your mouth, go to your IO configuration and figure it out. Because it's funny, I'll be asking them something, trying to lead them in the right place, because they'll have like a yellow triangle. We'll learn about the yellow triangle in just a second. But I'll be like, what's that, what was that tag name? They'll be local 1. I'm like, local what? Local 1, local what? Local 1. And finally, I'm like, local what? And finally, they'll say local : When you hear that colon come out of your mouth, go look at your I/O configuration, because that's what's really bridging us from the physical items out in the field to what's in our PLC program. So local colon 1, there's the 1 right there. So local colon 2, there's the 2 right there. Now let's go look at a 1769 that has a few modules on it. So in this case, local colon 1, that is your embedded discrete I/O. That's what's built into the compact Logix. Now, in this case, I added 2 expansion modules. Module number 1, that's going to be local colon 2. Module number 2, that's going to be local colon 3. It's just going to keep incrementing up. All right, so let's go back over here. That was a long ways to get us to where really we're going to start learning about our bit instructions. And also, so instructors, if you are looking to break this up, this probably is one of those breakpoints. So we learned how to create a program. We learned how to add our I/O configuration. And we learned our addressing. And so now we'll learn about the basic bit instructions. So we're going to go and add this third one here, bring that shape down. And let's get local colon 2 for our 5069 group. This is local colon 2 colon O. Whoops, and I'm breaking my own rules. We're going to follow our arrows and get that. Local colon 2 colon O, PT00, data. And since we filled in that description in our controller tag, since we started out, we laid out our I/O good there, then that's already done. Okay, so now I want to add another instruction here, and I want you to do it just because when y'all get fatigued, you end up doing this. I want you to click on the end because you feel like that's where you want to do it. And I want you to try to drag that instruction down, and notice it's not letting you. Everything's grayed out. So the first thing we got to do is we got to add a new line. These lines are called rungs, and so this H-looking symbol on the left side, that is a rung. So we're going to drag that one down. Then we're going to drag this next, the next instruction over, the second one, and then we'll grab another one of these and bring it down. Okay, now I actually want to look at this green button again. Now we could follow our arrows and we could go find that again, and that's good practice. But also, since I already have it here, I can click. Now, very carefully, I can click the tag name. Let's make sure we understand. The local thing is the tag name. The green button is the description, and the shape is in instruction. But if we click that tag name, then we can bring it down. And we want to bring it, you want to get this mouse pointer aimed into that green circle. What a lot of people want to do is they want to try to center this over this. But we'll learn later that you can accidentally end up on the wrong instructions. So we want to drop it right there. Now, the other thing people do is they think, well, this is a tag, the green button. We try to drag that down. Nope, that won't do it. That drags the whole thing. Or we grab the instruction. That does the same thing. All right, and then for this one, we're going to follow our arrows, and we're going to get local colon 2 colon O PT 00, and that's our yellow. Whoops, I said 00 and I did it. Sorry about that. We're going to get 01 data. All right, for the 5069 group, yours is exactly the same. We could almost even copy and paste it over, but we're going to bring down that third instruction. We're going to double click our question mark. We're going to get local colon 1 colon O data, and on the right side, we're going to grab 0. Oops, I didn't put the descriptions on this side. I need to go back over here, and actually for this video, because I'm getting a little long, I'm not going to do all of them. I'm only going to do the ones that I feel we're going to use, and we can fill them back with the rest of them. You want to fill yours in, but I'm just going to put the green light and the yellow light. There we go. Now that looks like that. We'll bring a new rung down. We'll bring this instruction right here down. And then we're going to bring this one down. And same thing, we can drag that shape down there. That way, both of these are looking at that green button. And then we'll follow our arrows, and we're going to get local colon 1 colon O data, and we're going to get 1. There we go. Okay, now we're ready to send this program to our PLC. And I want you to pause and make sure that we get this straight. We've talked about this already. But to send this program to our PLC, we are going to download it to our PLC. To pull the program out of a PLC, we will upload it. So we are going to go Communications, Who Active. And then in your case, you have probably a PLC of 192, 168, 110 if you're using our default trainer. Now, I am actually going to use this little subscribe one around here that we did in the communications exercise, but chances are you're under the ABETH1. Select your PLC, download. And very important, there's been too many lawyers involved in this whole thing right here. I don't want you to read this top line. Download offline project to the controller. To the controller may be the most important 3 words in this whole warning box, because you're so used to be on the internet. You're going to download a program, you're going to download Studio 5000, you're pulling things into your PC, but PLCs are the opposite of it. That's your last chance to realize it. To the controller, it tells us the direction we're going to go. So once you're sure that's what you want to do, then we're going to hit the download button. So while we're there, so we got a question there. Can you explain how to use ONS command, please? Yes, we're actually going to do that in probably the next video in this series. I can't decide yet. Either we're going to do timers and counters next, or we're going to do that. We'll do it along with the basic bit instructions. Oh, an excellent question, Logan. I'll answer that question while this is finishing up. No, I do not use aliases. In fact, outside of this class, I don't know that I have ever actually used aliases in a program. Now, here's 100% why. Now, you got to remember, I'm a technician. I came out of maintenance. I work on machines. I'm not a programmer. So, from a programmer's perspective, it'd be great if we had an alias called green button. That way, we didn't have to remember this local crap again. As a technician, when I press this green button and it doesn't work, the only thing I need to know is that local thingy. So the local thing is the piece, and this is really the piece I see missing from most people's programming classes. In fact, instructors, I know a lot of you using other trainers. Well, this is my video trainer. It is wired, but our trainers are not wired. That's really the downfall, I'll say, of almost every trainer out there on the market is they're pre-wired. They're made to look pretty. But no, we need to understand the wiring piece. And when we throw aliases in there right away, we just shoot ourselves in the foot as far as troubleshooting. All right, when we're done, we're going to get a prompt here to go back into remote run. Okay, now let's talk about the why of what I'm getting ready to show you here, or how I'm getting ready to explain this, because I think a lot of groups, just shrug their shoulder and like, oh yeah, that's what Tim does. Actually there was a very passionate discussion about a new software that just came out on this very thing. But this is, I believe I labeled this as something about basic bit instructions. So let's talk about what a bit is. A bit can really be 2 values. Now, if you Google a bit, it does say 0 and 1. But we're going to come back to that. We're going to talk about a couple things. We're going to talk about a few things that I see people do. First of all, we call it normally open, normally close. We call it true, false. We call it on, off. Now, here's my thing is, I want you to pick one. I don't care which one you pick, really. Now, I have a reason for the one I picked. But what I see us do is we call this contact, this wire to normally open. And then we try to call this a normally open instruction. And we just jumble all these terms. We try, and I always tell people when they're trying to explain it, doing all that, I'm like, I don't need a 32-page essay. I just need to know the basics. This is how we're going to break this up. So, yeah, it could be a 0, 1. Could be on, off. Could be true, false. Could be black, white. I mean, there's a lot of things we could call it, but let's eliminate a few of them. First of all, we have normally open and normally closed. Those are electrical contacts. Those are not programming instructions. So if we use normally open and normally closed electrical contacts and normally closed open instructions, then we're going to get really confused when we get in the weeds of a program as far as when is it what. So immediately I scratch those out. And a lot of people will be like, well, I had somebody the other day. They're like, yeah, it was hard at first, but after I did it a couple of years, I started to get the hang of it. Folks, I get people in my class that have never seen the inside of a PLC program, and it takes like 15 minutes to explain this. I'm like, a couple of years? Are you serious? And it's funny, I'll have somebody with like 20 years of experience come in, and they'll just shrug their shoulders when I say it, and they'll go along. But, they're never actually saying what I say. And about Wednesday, all the newcomers have blown past them as far as understanding PLCs. And usually Wednesday evening, they come up to me, they're like, So can you explain again how exactly you do this compared to what I do? So just hear me out on this, and if it works for you, great. If it doesn't work for you, great. But a very good example, normally up and normally closed. If you go to Siemens TIE portal, we're building out series on it. It uses normally up and normally closed. I explained it in a video in the exact same manner. I'm getting ready to explain this to you. And I had several Siemens instructors afterwards contact me like, wow, I've been teaching this for 20 years and nobody's ever explained it like that. It's so super easy. So let's eliminate a few things we can't call it. And then we'll be left with one thing that I think is really obvious for you to call it. So we can't do normally open and normally closed because those are electrical contacts. Another one we hear is on off. Well, this PLC input is already taken on off. So if we go and hopefully the module properties works this time, if we double click on our 5069 IB16, and by miracle, please, thank you, the module properties did come up. And then we go to our points here. We're using on off for them transitioning to theirs. Now, even here, I usually use, do I have current? Do I not? And we can talk in a later troubleshooting video about why. But this makes it where we can't use on and off for these instructions, even though I know right up here it says examine on, right up here it says examine off. We can't really use those. Now, the other one, and this was a heated argument just this week, is can we call them true false? Well, you're going to, if you ever come to class, you're going to hear right click, you get options. So if I right click this instruction, I go to instruction help. Rockwell Automation has an excellent documentation in their instruction help. And the big thing I'm always looking at when we're trying to figure out what's really going on is this execution ladder diagram. And we'll learn about what the pre-scan and post-scan is probably actually in the next video or right after timers and counters. But really, we have condition in as true, condition in as false. So that means we can't use those. So we've eliminated being able to use normally open, normally closed. We've eliminated being able to use on, off. And we've eliminated being able to use true, false. Now, the one, if you actually go and you Google what a bit is going to be 0 and 1. And in our controller tags, if we look at them, we have values of 0 and 1. Whoops, let me get over the value column. And so right now, whoops, I'm going to local colon 1 colon I, and either way to input 0. So we have local colon 1 PT00.data. Right now the green button is not pressed. It has a 0 in it. We press it, it gets a 1 in it. So that's kind of the background of why I'm getting ready to show you the way I do it and the way it makes sense. Is in the end, for this to be true, this has to have a 1 in it. So I call this a go look for a 1. In fact, just so we can break this out, I'm going to drag this tab out just so we make sure we're all on the same page. Oops, I didn't want to do the split screen. I accidentally do that all the time. Now we'll do it. I don't even want to look at that output side. I just want you to look at this one instruction. So this instruction goes and looks for a 1, and we mouse over it. Oops, if I get my mouse to park, it has a 0. So it is false. Period, the end. That's all that instruction does. So now I'm going to press my green button. Don't worry about the green on the screen yet. We're just talking this out. It's looking for 1. It sees a 1, so it is true. Period, the end of the discussion. All right, that means that over here, we can pass either a true condition or a false condition to this output energize. A false output energize is going to go right to 0. Where to? Local colon 2 colon 0 PT00.data. So right now it is false. And if it's true, it's going to go right to 1. Where to? Local colon 2 colon 0 PT00.data. So it makes us have this instruction. You can kind of already see that it's turning green when you're not pressed. And here's where all of a sudden I hear, well, if the normally open contact is wired to the normally closed contact and it's not pressed, and I'm like, what are you even saying? This instruction right here goes and looks for a 0. If it sees a 0, it'll be true. Press the green button, it's looking for a 0. If it sees a 1, it will be false. And that's all there is to it. And I've already even filled it in, whoops, and all my crazy rebooting, I took down that But if we go back, sorry, I mean, yes, I don't write a lot of description in this because everybody mainly said they wanted videos. But if we go back to this course, even though we haven't even finished this live stream, I've only written one piece of it out, and that's right here. Is the XIC, go look for a 1. If it sees a 1, it will be true. If it sees a 0, then it'll be false. XIO, go look for a 0. If it sees a 0, it'll be true. If it sees a 1, then it'll be false. OTE, if you can trace its continuous path of truths, and we'll talk about exactly what a continuous path of truths in the next step is, from left to right to the OTE, then it will be true. Otherwise, it will be false. And a true one goes right to 1, and a false one goes right to 0. And honestly, I probably taught more students off the ledge of dropping their class off of that little bit of description right there than anything else, because they'll be like, yeah, I can't figure any of this stuff out. They're talking about examinative off or examinative closed, and I can't figure out what closed and open. I don't know what any of this means. And I walk through that a little bit, and they're like, oh, well, that was easy. So just think through that one. And let's talk about a couple other things here. So that gets us through that basic one. Now let's talk about how we could piece this together and do, a little bit of a logic building. Mainly, we're going to talk about 3 words that really join our stuff together as we're talking our logic out that we can do things. Also, instructors, if you're looking for a break in this probably is the next break because, we learned about what those 3 instructions do. Now we're going to make a basic start-stop out of it just so we can understand how we can piece this together. So we could do online edits, but I want to kick that can down the road a little bit further. We're going to go communications, and we're going to go offline. And then we're done with rung 1 for now. So I'm just going to highlight rung 1 next, and I'm not even going to use the keyboard. I'm going to right-click rung 1. I'm going to delete rung. That gets us to here. And then I want to make this where when I press the green button, it starts it. And when I let off the green button, it stays running. We're going to start with that little bit right there. So what I always say is, okay, now we need to remember that either the green button was pressed or the green light was on. And all my electricians out there are going to be like, oh, yeah, we need a seal-in. And you're 100% right. This is called a seal-in. Some people call it a holding circuit, a memory circuit. We do call it a latching circuit. I don't get excited about the latching circuit. But yeah, so this one, here's a good example. Notice I was on the end. You deleted and you're on the end, and you're going to try to drag this thing down. You're going to be like, oh, my stuff's grayed out. Well, nope, we got to get back up here on this. And then I want you to drag down this branch. It's the thing to the right of the new rung. And we're going to drop it in. Okay, and notice when you drop it in with this really tall blue line right here, if you grab the tall blue line, then you can drag this to any of these green spots that you see here. Now, what a lot of people do is they end up clicking here, and this actually moves the whole thing, and that gets really complicated. Now, where we grab it here, and we can't figure out why it won't move. We got to click the right-hand side of the branch. That gets the tall blue line going, and we can drag it over. So we want to remember that the green light was on. So we're going to drag down. I'll go look for a 1 because if the green light was on, this would have written a 1. And here's another time that this is the tag we're looking for. So we're going to drag it right over to there. And yes, I know we won't be able to turn the green light off, but we're going to download this so that way we understand exactly how this works, and then we'll get that part fixed. I got communications to active, and I know you had a download button there, but I do want you to get communications to active every time. Because I want you to do a visual check, and I want you to make sure that this is the IP address that you wanted, and then just do a reality check. Make sure that sounds like your machine name. And yeah, do that final reality check and make sure that you did want to hit that download button to the controller. But yeah, the reason I don't want you doing the communications download or just hitting a little drop down and hitting download is it's not until all of a sudden it gets costly that the lessons really stick with you. I want to try to keep you out of that. But I was in a hurry one day. We'll learn about arrays later. But if you have an array, then you cannot make it larger while you're online. And so I needed to run out really fast and expand an array. And there were 4 lines that are exactly the same. And so I get a I ran out there and I'm like, hey, can you stop for this just a second so I can make a download? They're like, yeah. They hit the download button. And even notice while I'm sitting there downloading, the indicator light on the control panel is still blinking. And I'm like, well, that seems really strange. I was on line 1, and about that time I hear, maintenance, please come to line 3. Maintenance, please come to line 3. About the time I realized, oh, and I just downloaded to the wrong PLC. So just take your hand off the mouse, do a pause, make sure it's the one you want. Then we're going to put it back in the run mode. All right, let's talk this out before you hit anything. So this instruction goes and looks for a 1. Mouse over it. Does it have one? No. So this is false. Now, a little bit about operation. It's going to do this, then it's going to come to this branch. It's hard for me to highlight that branch, the top of that branch, and then it's going to come here, and then it's going to do this instruction. Now we have an output in this instruction. That does not matter. This is a box the same as any other box. This instruction is going to go look for a 1 at local:2:0 PT00.data. It has a 0, so it is false. Now, can I trace a continuous path of truths from the rung number to my output energize? This is false. This is false. So I cannot, and that means this is false. Now, very important. Just because it's false doesn't mean we ignore it, because a false output energize goes and writes a 0. So I got to get one of these true to get it so to move for it. So I'm going to press the green button. We're going to do this a little slow as we're talking. I know immediately you're going to see it and you're like, oh, okay, but let's talk it out. We're going to act like we're going insanely slow motion. So when I press this green button, we're going to imagine there was a 1 here. That will become true. It'll go here, then here. This is going to look for a 1. At that very moment in time, this will still have a 0. So this will be false. Now, I will have a continuous path of truths from left to right through that top branch. That's going to write a 1 to the green light. Now, next scan around, this is still looking for a 1. It'll see a 1, so it'll be true. It'll go here. It'll go here. Now this is going to look for a 1. It's going to see a 1, so it'll also be true. Doesn't matter that we have 2 truths as long as we can trace a path of truths from left to right. Then this will be true, and it'll go right at once. So we press the button. Whoops, I let off of it. So that made that true. Then we got our seal in, as people, as my electricians like to call it. And when we let off the green button, then that will hold it in. And that is half of our start-stop circuit, which gets us to, now we need to be able to stop it. And that's going to be button 3. We're going to use our red button. And we're going to have a learning opportunity right here because, yeah, before somebody throws in the chat, no, I have not wired this wrong. But what we're going to do is let's go ahead and go offline. So communications, go offline. And now we want to stop it with the red light, which means we need to break this continuous path of truths from left to right. Now, you do see this different ways. We could put a break right here at the beginning. We could have put a break here. We could put break into this area right here. But yeah, now our question is, which instruction do we need? And so here's where the go look for a 1 and the go look for a 0 starts to make this really easy for us to understand, because it's not a matter of normally open, normally close, what contact, all this stuff. It's what value is it when it is not pressed? Because we don't want the operator to sit there and have to hold the button the whole time. We want it to go false when they press it. So the button's not pressed. We are wired to a normally open contact. We'll get to that in a second. So its normal value is a 0. It is normally off. So we're going to bring a go look for a 0 down. And then we're going to double click on our question mark. We're going to go to local:1:I PT02, which also, if you're not sure, if you're like, I don't remember which one I wired it to, as you slowly mouse over these, you are getting the description at the bottom of them. So we'll open up local:1:I PT02 data. Or in the case of the 1769 group, that is local:1:I local:1:O.data 0.2. And let's go ahead and download that. Now, while that's downloading, let me explain this normally open, normally closed stop that area. When I do this exercise, everybody's like, Tim, you wired that normally, you wired that stop wrong. It's not safe. Okay. Now, if we're going to talk safety, we got to start explaining why this PLC is red. Just because you wire it to a normally closed stop does not make anything any safer. Now, we could argue, well, what if the wire gets cut? Wouldn't that make it stop? Well, yeah. Well, what if the contact falls off the back of a normally closed contact? Well, that's going to make it where it doesn't work too. So we start talking safety, we got to start talking redundancy. Now, if we're coming out of the old school electrician trade, it had to be normally closed. And that's why most of them are normally closed. But, in our getting started guide, we do wire, oops, I forgot to hit the download button while I'm talking. We wire it normally open, and it's a good example where we have to use a go look for a 1 and a go look for a 0 here. So I click yes to put it back in run mode. And so now let's just talk it out one more time here. This is looking for a 1. It has a 0, so it is false. And then it goes to this little corner up here, and then it goes here. This is looking for a 1. We mouse over it. It has a 0, so it is false. Now, a lot of people will just skip that point, be like, nope, no, I still want you to do every single instruction. The PLC does every single instruction. We're going to do it too. This is looking for a 0. We mouse over it. It has a value of 0, so it is true. Now, still, I can't trace a path of truth from left to my OTE, so this is false, and a false output energize writes a 0. But now, as soon as I press the green button, this one will come true. Now, even though it's true, it'll still go down here and scan this one. At that very moment in time, this will be false, but then we would have a contingency path of truth from left to right, and that'll write a 1 to local colon 2 colon OPT00.data. And then this is looking for 1. The next scan around, it would have 1, and that would be our seal in. So we press our green button, and that seals in our green light. And then finally, we press our red button, and that'll drop out. So that is our basic start-stop circuit. Now, in all that, there are 3 very important words that if we'll understand these 3 important words, then we can work our way through any program, and we can write any basic bit program with what we have now. So this right here is saying, go look for 1 at the green button. And then we have this branch right here. This branch, when you see a branch, you want to say or. So we go look for a 1 at the green button, or we go look for a 1 at the green light. Now here, this little piece right here, this I struggle so much. This one right here, maybe the one I struggle to get folks to say. When you see things in series, that's an and. So and, we're looking for a 0 at the red button. That would be that. Okay, so if we're actually talking it out, though, there's one more word when you see this, because, yeah, I know I say go look for 1, go look for 0, but eventually we got to be able to talk it out. So this is looking for the green button to be pressed, or the green light to be on, and the red button, and when you see the go look for 0, not to be pressed. Turn on the green light. And those words right there will get you through the bulk of the programs. That gets us through our basic bit instructions. Now, a couple things on that. Our next one, I believe, because I'm still bouncing back and forth, either we're going to do timers and then counters, then we're going to do the latch, unlatch, the one-shots that y'all are asking about. Or we may go ahead and do the latch, unlatch, and then timers and counters. Not really sure which way. I think I'll do timers and counters next because that's usually what people want to see next.